In this video, we look at the concept of data types and casting. So we've already gone over variables and constants and data types to a slightly lesser degree in a previous video. So as you may be aware, variables and constants can hold data that must be of a certain type. And the data types you need to know about for the exam are integers, real, character, string and boolean. Now each data type uses a different amount of memory, and therefore to optimize your programs, the correct data type should be used. You can see an example here of the number 22. It's been stored in the left in an integer and on the right in a float. They're both holding exactly the same number, but the real or the float is taking up far more room in memory. If we were only ever going to be storing whole numbers, it would be silly to store 22 as a real or float, so we would store it as preference as an integer. We're going to use the analogy here of a beat the dice program, which we've been looking at in a couple of videos to talk about another concept. So with beat the dice, a player rolls 2 dice. The order of the dice is determined by the value, and the highest value comes first. So if a 4 and a 6 was rolled, the result would be 64, not 10, 64. We're using two variables here called dice1 and dice2, and we can see them there, and we've declared them and we've assigned them the values 0. We know that our dice1 and dice2 variables are only going to ever hold the whole numbers 1 through 6, because these are the numbers that appear on the faces of a dice. And therefore, the variables dice1 and dice2 are stored as integer data types, as integers can only hold whole numbers. Later on in our code, you can see we then compare the numbers, and depending which is greater, we join them together. Now, in order to concatenate them, join them together, and simply not add them as you would with maths, we need to store them as strings. So if dice1 equals 8 and dice2 equals 5, if they were stored as integers, the result will be 13, because the integer 8 plus the integer 5 is 13. If they're stored as strings, then dice1 plus dice2 is 8, 5. Because 8 concatenated with 5 is 85. So we have a need here to cast or convert one data type to another. And we do that with the str command, which converts a data type into a string. And we're able to convert from pretty much any data type to any other data type. It is easy to convert string data types back into integers, or indeed to other data types like I've just said, so we can perform arithmetic operations on their values. We quite often ask the user to enter numbers via the keyboard, but any value entered from the keyboard is inputted as characters, even if we often want them stored internally as numbers. So when someone presses 6 on the keyboard, they are not entering the number 6, they're entering the ASCII character 6. So it's quite common to cast or convert them into integers. So here we have a line of code, choice equals int, input, enter your choice. That's taking an input from the user, they press a key on their keyboard, and the result of that key is then cast or converted into an integer data type. So just a quick recap then. Variables and constants can hold integers, that's whole numbers, positive or negative. Reals or floats, that's numbers with a decimal part. Characters, that's a single alphanumeric character. Strings, a set of characters. Or booleans, which are true or false and often called flags. We typically use these to track if something has happened or not. Changing a data type from one type to another is known as casting. And casting is necessary so that subproblems receive data in the format that they are expecting. Casting allows numbers to be manipulated as strings, and casting allows inputs that are always strings to become numbers. So one other thing you have to be able to do under exam conditions is to be able to select suitable data types based on a given scenario. So here's a typical example you might see in an exam. A program is to be written which asks a user's name, age and telephone number. If they are aged 17 or under, it informs them they are not eligible to vote as they're too young. If they're 18 or over, it stores their details and tells them they are eligible to vote. So the first thing you have to do is study the scenario and work out all the variables that you would need. Well, the program is asking the user for their name, their age and their telephone number, so it seems sensible that these need to be variables, and I've called them name, age and telephone number. But it's also storing their eligibility to vote, so I've got one more variable called vote. So you can see I've listed those down the left hand side, and each of those variables now needs to be assigned a data type. So are those variables going to hold a string, an integer, a real or a boolean? Why don't you pause the video and see if you can have a go yourself, and then unpause it and see if you got it right. So there's the answer. Vote should clearly be a boolean because it's either going to be storing true or false. They are eligible to vote or they're not. Name is clearly going to be a string as it's a series of alphanumeric characters, and age is going to be an integer, presuming they enter their age as a whole number. Finally, telephone number should be a string. Now let's just talk about that last one for a quick second. Many students often choose integer in the exams when they see telephone number. Oh yeah, telephone number's it's a string of numbers. I'll store that as an integer. Telephone numbers don't have fractional or decimal points. But that is wrong and it often catches people out. Can you explain why telephone number must be stored as a string? Well, the answer comes down to the nature of a telephone number. Most telephone numbers start with 0. For example here, 07548 433 844. If you asked the computer to store that as an integer, it would lop off the leading 0. And of course this would no longer be a valid telephone number. Numbers also are often entered as telephone numbers with symbols. So people will sometimes go brackets 07548 brackets 433-844. And of course again, integers only support whole numbers. So this is why telephone numbers should always be stored as strings.